Hello guys, welcome once more to another video in our YouTube channel. So in this video we are going to look at the Southwest Regional Mock Further Maths Paper 2, question number 10. It's a question from sequences, recursive sequences and series. So without wasting much of your time, let's get started. Alright, the question reads, a sequence is defined recursively by un defined by u0 is equal to -1, u1 is 4, un plus 2 is 1/3, un plus 1 plus 2/3 un. Given also that another sequence vn is defined by vn equal to un plus 1 minus un for all natural numbers n. Roman 1, show that vn is a convergent geometric sequence and express vn in terms of n. Roman 2, by evaluating the sum from r equal to 0 to n minus 1 of vn equal to the sum from r equal to 0 to n minus 1 of un plus 1 minus un, show that un is equal to 2 minus 3 times -2/3 raised to the power n. Hence, find the limit as n tends to plus infinity of un. Pay keen attention to the analysis of this question. Thank you. Okay, so the first part of the equation, we are supposed to show that Vn is a convergent geometric sequence, and then we express Vn in terms of n. So showing that it's a convergent geometric sequence, we need to show that it is geometric, then later we show that it is convergent. Okay, so let's begin by showing that it is geometric, then later we now show that it is convergent. So for us to show that a sequence is geometric, we need to show that the ratio between the n plus 1 term and the n term is a constant, and to show that it is convergent, we now need to show that the absolute value of that ratio is less than 1. That ratio is called the common ratio. So doing this, then we have proven that the sequence is a convergent geometric sequence. So let us begin by finding Vn plus 1. Since our Vn is equal to un plus 1 minus un, we need to step up, and stepping up, we need to replace n with n plus 1, we replace n with n plus 1, and we replace n with n plus 1. We are going to get Vn plus 1 to be un plus 2 minus un plus 1. But the recursive definition of un permits us to rewrite un plus 2 as 1/3 un plus 1 plus 2/3 un. Then we now subtract this un plus 1. Okay, now we need to bring like terms together. 1/3 un plus 1 minus un plus 1 is -2/3 un plus 1. Then we need to add this un, this 2/3 un. We factorize -2/3. We are going to get un plus 1 here, but when we are factorizing a negative sign from a positive sign, we get a negative sign. Okay, and then we are going to get -2/3 into un plus 1 minus un. But un plus 1 minus un is vn, so it therefore means from here we can divide both sides by the vn, and we get that vn plus 1 divided by vn is -2/3. So this is a constant, we can call it a common ratio. So doing this, we have proven that vn is a geometric sequence. Now, how then do we proceed to prove that it is convergent? We know that if you are a convergent sequence and geometric, then the absolute value or the magnitude of your common ratio has to be less than 1. So the magnitude of -2/3 is actually equal to 2/3, and 2/3 is less than 1. So with this, we can conclude that it is convergent. So at the end of the day, we have shown that Vn is a convergent geometric sequence. Now the next part of the equation is asking us to express Vn in terms of n. So Vn is equal to its first term times the common ratio raised to the power n. The first term could be v1 or v0 or v2, but we need to check the definition of vn, since they said for all natural numbers. Okay, and you realize that n can actually begin from 0. Since u0 exists, it means that my first term of vn will be v0. So it means that I'm going to have n plus 1 terms, since I'm going to begin from 0 to n. And normally the formula is ar to the n minus 1, where the n there is a number of terms. But here, if I begin from 0 and I end at n, I actually have n plus 1 terms, because from 1 to n there are n terms. So if I'm adding 0, it means that I have added 1 term, so it becomes n plus 1. So in the actual formula of ar to the n minus 1, if you replace the n there with n plus 1, then we are just going to have the resulting power of r to the n. Okay, if you check previous videos on recursive sequences, I've explained this detailing. Okay, so Vn is V0 r to the n, and what is r? R is negative 2/3. What about V0? V0 is u1 minus u0 by replacing n with 0. So V0 is u1 minus u0. u1 is 4 and u0 is negative 1. 4 minus negative 1 is 5. So it therefore means that our Vn is 5 times negative 2/3 raised to the power n. So we have proven that it is convergent geometric, and we have found its end term. Okay, now by evaluating this sum, show that un is equal to 2 minus negative 2/3 to the n, and later find the limit of un. Okay, so let us evaluate the sum. So this is the sum we are evaluating. Okay, so this sum, to evaluate this type of sums, we just need to replace the values of, oh, this is supposed to be r, we need to replace the values of r. Okay, this is supposed to be r, sorry, we need to replace the values of r. When we replace the values of r, then from there now we can see what to do. So I'm just trying to correct, in the place of n is supposed to be r, since you are summing from r to n. Okay, now let's begin with replacing r to be 0. When we replace r to be 0, the very first term is going to be u1 minus u0. That's going to be the first term. Now when I replace r to be 1, what is the next term? Is going to be u2 minus u1. Okay, now when I replace r to be 2, what's the next term? I'm going to have u3 minus u2, and so on and so forth. So let's now replace r to be n minus 1, no, to be n minus 2, since you are ending at n minus 1. So if I replace r to be n minus 2, what will be here will be n minus 1, because you need to take n minus 2 then plus 1. Okay, we are just replacing just the r with n minus 2, but now there is a plus 1 here. But for this subscript here, it's just going to remain n minus 2. Okay, so the term before the n minus 1 term is the n minus 2 term, and the n minus 2 term is un minus 1 minus un minus 2. So the last term, which is the n minus 1 term, since you are ending at n minus 1, we will be replacing r with n minus 1. Then r plus 1 will just be equal to n, since you are replacing r with n minus 1. But this r here will remain the n minus 1. Okay, so that is what we have. Now this sum is what we call a telescopic sum. Why do we call this a telescopic sum? It is because terms are falling off. Look at u1. Look at the u1 in the next term. u1 minus u1 is 0, so u1 is gone forever. Now u0 will never go. Okay, it's not possible for it to go. Look at it very well. But look at u2 in the second term, and look at u2 in the third term. u2 is going to disappear. It therefore means that u3 will disappear. If maybe we included some terms inside here, u3 will definitely disappear. Also, this un minus 2 carries a negative sign. It's going to also disappear if we included the term before this term. Just try to include the term before this term, and you realize that un minus 2 will disappear. Now look at un minus 1 and negative un minus 1. So un minus 1 is going to disappear. So the only two terms that will be left will be negative u0 and positive un. So it means that this sum will simplify to negative u0 plus un. But this sum is equivalent to summing the sequence VR. But the sequence VR is just basically 5 times negative 2/3 raised to the power r. It's r again, not n. Sorry for the error. So that is a sequence VR, and this is a geometric sequence. Okay, so this sum is equal to negative u0 plus un. So we know how to find the sum of a GP. We need to take the first term divided by 1 minus the common ratio. No, we need to take the first term into 1 minus the common ratio to the n divided by 1 minus the common ratio, because here we have n terms. Remember, we are beginning from 0 and we are ending at n minus 1, so there are n terms. If we began from 0 and we were ending at n, there are going to be n plus 1 terms. But because we are ending at a term which is behind n, then we have removed that 1 term, so we just have n terms. So the sum of the first n terms of this geometric sequence is the first term, which is 5, into 1 minus the common ratio to the n divided by 1 minus the common ratio. 1 minus 2 on 3, 1 minus negative 2/3 is 5 on 3. The 5 will cancel with this in the numerator and the 3 will go to the numerator. If we simplify perfectly, you are going to have that 3 into the numerator here will give you, if you add u0 on both sides, you're going to have all of this. Okay, when you simplify this, the 5 denominator will give you 5 on 3. Now 5 will cancel the 5 in the denominator, but the denominator also has another denominator, and since we have an original denominator here, then the 3 would normally reverse and go back to the numerator. So here is a 3 meeting what is in the numerator. Then we need to add u0 on both sides since we are finding un, but we know that u0 is -1, so we have -1 plus, now if we expand this, we have 3 times 1 and 3 times this whole quantity. -1 plus 3 is 2, therefore means that un is equal to 2 minus 3 times -2 third raised to the power n. So that is a proof. Finally, we need to find the limit of un. Okay, so the limit of un is a limit as n tends to infinity, and as n tends to infinity, since 2/3 is less than 1, then everything here gives us 0. Okay, therefore the limit of un will just be equal to 2. So the limit of un is 2. There was no time to prepare another slide to find the limit of un. That's why I just concluded here. Okay guys, if there is any question you have to ask, make sure you ask your question in the comment section. Like the video, share the video with your friends, and also don't forget to comment. Thank you once more and see you in the next video.